In the previous lecture, we set up the GUI, the graphical user interface, for our course application, the store inventory application. It looks pretty good so far, but it's missing something significant: functionality. In this lecture, we're going to begin to add functionality to our interface. Unlike with console applications where the interaction with the user is fairly linear with text commands and prompts issued back and forth, with GUI applications we use an event-driven architecture. This means that the application waits for events to occur and responds accordingly. The interaction is more dynamic, and the order of interactions isn't always quite as predictable as with a console application. In a fundamental event-driven system, there are typically three major components that we recognize: the event source, which is where the event originated; the event, which is the actual event itself; and the event handler, which is the method, function, that responds to the event that has occurred. In Qt, we commonly refer to the event as a signal and the event handler as a slot. This topic can go very deep in Qt, but we only really need the basics for our purposes in creating this application. We have to call a special function called connect in order to perform the association between the event source and the event handler. For example, I might use the connect function to say, when this button is clicked, execute the function named handleButton. So in this case, the button is the event source, the click event is the signal, and the handle button is the slot. We'll be jumping around a bit to get different parts functioning, since this course is geared more towards students and professionals who are interested in how we might go about developing this application. Some of what you observe will be a possible workflow I might use. Before we get started, I'd like to mention that there is a collection of images that are available to you as a resource with this lecture. Those can be used for the application, or you can make or use your own. So let's get to work and add some of the core functionality. We'll start with the main window. First, let's create part of the data model that will be used. In the private section of the header file, mainWindow.h, which we'll go to right now, so we've got the private section of the header file. We're going to add a QVector of item pointers. So we also need to include item.h at the top in order to access that class. So include item.h. Now here at the bottom, we're going to add this QVector of item pointers, which we'll call product list. Now in the main window UI file, we're going to change the window title to Store Inventory Application. So go to the main window UI file, and we're going to change this title here to window title to Store Inventory Application. There we go. So now it won't say just main window in the title bar. In the Add Item Dialog UI file, which we're going to open here, Add Item Dialog UI, we're going to change the window title to Add Item in the Properties Editor. So window title, we'll just call this Add Item. There we go. And now what we're going to do in the Add Item Dialog.h to start out with, we're going to add a confirm add function and a load item image function that will be associated with the buttons. And I'm going to say item, and this is the first thing I'm going to do is add some stuff here. So double pointer, new item. That's a double pointer so that it can point to the pointer in order to modify the actual pointer. I know that seems a little bit confusing, but it's, if you did a single pointer, you could modify the stuff that the actual object holds, but the double pointer allows us to point to a completely new memory location, which we'll need. So we need that stuff first, and we're going to put void confirm add and void load item image right there. And We're going to pass a new item pointer by reference so that the pointer itself can be modified to the constructor right here. So this is going to take an item pointer, and then we'll make it by reference. New item, Q widget, pointer parent equals null pointer. So there we go. Now it doesn't know what item pointer is, so I'll include that at the top. And these were kind of the main idea that we were going to work with. We have to implement these confirm add and load item image functions. All right, so let's go over to add item dialog.cpp, and over here set the new item. Oh, I guess this has to be taken care of too. We want to do the parent can stay there, but we'll do item star reference new item. There we go, makes the error go away. And now I'm going to say this new item equals the, and this is the address of operator, so it's basically saying give me the pointer of that new item, and I want the field that I'm referencing in my .h file to point to that, or to actually hold the address of that same item that was passed in. So we'll do that. Image file path equals none.png. That's going to be the default. So now when you click the button, we want the confirm add function to execute and the load function to execute, load item image function to execute when you click the load image button. So we could get those started over here. Void add item dialog will say confirm add first, I suppose. That's fine. And then add item dialog load item image. So that's the two functions we need to implement. Okay, there we go. Now let's do the association. So this is going to be registering the events. So for this one, we're going to call connect UI btn confirm add, and this takes a reference to the event. So Q push button, it's a static piece of data called clicked. This, meaning the handler will be from inside of this particular class, and add item dialog confirm add. Next one, btn load image. That's also a Q push button, and it's the clicked event again with this. And then add item dialog, we want it to call the load item image. Now, one other thing, when we start working with images, we're going to need to do this right here. I'm going to set the path directory here. Guess I'll call it path dir. And I'm going to put just ./images. And it doesn't know what qdir is. So I could do an alt enter and it gives me suggestions. And I could include that. So I could just do that. That's fine. Or I could just type it, include dir at the top. That's fine also. If not path.pathdir.exists, meaning if it does not exist, we're going to create it. So the way we do that is we have the qdir make dir method. For those of you familiar with like Unix and Linux commands on the command line, these are already built-in text-based interaction commands like make dir. That means make the directory. And in this case, it doesn't matter if you're on a Mac or a Linux machine or Windows, even though Windows uses the opposite side slash. When we're inside of Qt, we use more of the Linux or Mac style slashes, and whatever system you're on, it'll automatically take care of everything for you. So it's pretty cool. So basically we say, hey, is there this images folder? And if it does not exist, create it. So that gets it ready for the images that we might want. Now we might want to fill in some of this code here. So in confirm add, I'm actually going to hit enter a couple times down here. And for confirm add, we're going to say QString product name, and we're going to grab that from that txt product name that we had earlier, and that also has a text method associated with it. And then we want the quantity. We're going to say the quantity is equal to the UI. Oh, I thought we called it SB quantity. You know what? Let's fix that. Let's go over into add item dialog. And this should be called SB quantity. I guess we had not fixed that. And we'll go back now to add item dialog.cpp. Okay. So SB, I think what we should do actually is we'll save this, and I'm going to call build, and that should update the UI. So int quantity equals UI SB quantity. There we go. Got it now. And then we call the value method on that. Good. So product name dot trimmed. So that basically takes any white space off the front and the end. So product name dot trimmed not equal to empty, and quantity greater than or equal to 1. So we might want to make sure that they don't have an empty product name and that they have at least one quantity selected. So now what we're going to do is we're going to populate the new item, a new item object that was sent in through the constructor, right? And we held it inside of the, as a private data member, new item. And what we're going to do is we're going to populate it with a brand new item. That's why we needed a double pointer, because we have to be able to say star to dereference it. So that's just a single pointer now. Equals new item. And we're going to pass it product name, quantity, and image file path. There we go. And then we're going to say this should just be close. And then if something went wrong where they did not put in the full product name, or the quantity somehow is not at least 1, we're going to use a Q message box. I'm going to just call it MB. You notice it doesn't know what message box is, so you could just type it out, or I'm just going to click inside of it, do Alt Enter, and there we go, include Q message box. So that just puts it at the very top right here, Q message box. And what I'm going to do is I'm just going to say mb.set the text to say you must have a valid name and a quantity of at least 1. There we go. That sets the text. And then mb.exec actually causes the message box to show. So there we go. That's pretty much all we need for confirm add. Now for load item image, this has some tricky stuff in it, but it's not too bad. So QString file name, and we're going to say file name is equal to Q file dialog, and it doesn't know what that is, so we're going to do Alt Enter and add that. I'm going to say colon colon, then I get my intelligent sense there, so get open file name, and that's the parent window. I'm going to say open image. This is going to be the dialog that pops up. So .png space star.jpg. This is going to be the dialog that pops up when the user clicks on load item image. And it's going to basically say, hey, it's the open image. That's the title. It's going to start in the current directory. That's what ./ means. And that's not just a Qt specific thing. That's, again, more of a command line Linux type style. It also is the same as Windows. Dot means current directory. Dot means the directory above me. And image files right here, this is going to be what's displayed to the user. And as long as the file name is not empty, so we know that they didn't hit cancel. Then we're going to grab the short name of the file, so int last slash. This is how I'm going to do it. There's multiple ways to do it, but this is just so we can flex a little bit of our muscles with the Q string and a couple other things. So I'm going to say last index of. I'm going to find the last index of the last forward slash in the path. So even if the path starts at C drive and goes all the way down several layers, I'm going to grab the last slash that occurs right before the name of the actual image. And now we're going to return the rightmost characters. So Q string short name is going to be file name dot right of the file name dot size, a little bit of math here, last slash -1. So that's actually going to give me just the name of the file, whatever it is, whether it's orange.png or videogame.jpg, it's going to give me that based on what I've done here. So the whole file name size minus the last slash, and then -1 because we have an off by 1 situation because indices start at 0. Now what we're going to do is we're going to do a little bit of really cool file manipulation using what we know here. So I'm going to take that Q string and we're actually going to do Q file and call this function called copy. And it takes the file name and I'm going to put it in the directory images that we have, because that's when we launched the main window, it created it if it didn't exist already. And then concatenate short name right there. Pretty cool. So it's actually going to take wherever the original file name, that means wherever the original file was, wherever we selected it from, it's going to copy it and put it into the local images directory for our program so that even if they delete the original, we're not going to have a problem. Really cool. So this is pretty sophisticated, right? So now I need to actually load that image into that label. Now the way you do that in Qt is, there's a couple ways, but QPixMap is one of the ways we can do that. And again, images slash short name, because now it's there. And then I'll say label image, UI label image, set pixmap to pixmap. Then I'm going to say UI label image set scaled contents, and I'm going to put that to true. Now pay attention close to that. If I didn't do this, it would cut off part of the image if it's too big. It would look distorted. There'd be all kinds of potential problems. So set scaled contents. It might still look a little distorted, but it'll actually fit in the label that we have for it. Now update the internal data representing the file path. So image file path is equal to images slash short name. There we go. Make sure I spelled everything correctly. So images, images, images. Looks good. In order to actually test what we've done, though, we need to switch back to the main window because we need to create an instance and use the instance of the add item dialog class. And we have to launch it from main window. So we need to associate the main window's menu option, menu new product, with opening the add item dialog. So we also have to make sure that the add item dialog is modal, meaning that the dialog must be acknowledged before it'll let us go back to the main window. So when it shows up, it'll just sit there, and if we try to click around it, it won't let us. It'll make us acknowledge it in some way. So that's what we're going to do. Make sure this is saved, this file. We're going to go to the main window.h file, and we're going to add the event handler, the slot, to handle the clicking of the new product menu item. So in here, we're going to add void handle menu item new right there. And I'm just going to actually copy that because we're going to connect it over in the main window.cpp. That's our, actually I'm going to give it a empty body first. Let's do that. And I'm going to highlight that and shift tab to move it over. Now I have to connect it or we're not going to have much luck here. So menu new product. And then this time it's not actually a clicked event, and it's not through push button because it's not a push button. So for menu items, you do Q action, and then you get the triggered event. All right, main window, handle menu item new. Notice that's, again, it's not a function call. There's no parentheses after it. Like, it doesn't look like that. So you're just pointing basically to the name. There's the closing parenthesis for this, but there's no set of parentheses there because you're pointing to that name. All right. And of course, we need to write the event handler for handling the new menu item. So inside of here, I'm going to actually push this up a little bit. Inside of here, we're going to create an instance of the add item dialog. So first, though, we have to create our item. New item, we'll set it to null pointer because it's not pointing to anything yet. Add item dialog, which it's not aware of yet. So we'll do Alt Enter, and it's not really sure what to do. It thinks maybe there's a thing called add item dialog.h. We're going to actually use the one we made, add item dialog.h, in the double quotes right there. We're going to do that. So once we do that, add item dialog is the identifier, and we're going to pass it new item. It's passed by reference, and then null pointer. If we put null pointer there, that means the parent will be set to null pointer. We could actually just not pass that, and it'll do the same thing because that's the default value, but I figured why be lazy. Now, add item dialog dot set modal, so we're setting it to modal, and then add item dialog. We're going to call exec, just like we did with the message box earlier. We're going to call this. We have to think about how this works. When they hit either cancel, or the X in the corner rather, or they confirm it, then the new item, if it still has null pointer, that means it was never changed if they canceled it. Now, if it does have something other than null pointer, we know that they did select something. So here's what we're going to do. We have to fix two things anytime an item is modified. We have to change two things. So new item, not equal to null pointer. So this tells us, hey, we can do this. So product list, and let's see here, product list dot push back the new item. Says it's use of undeclared. Oh, that's why. We haven't included the handle menu item in the scope of this class yet, so we needed to do that. Otherwise, it just thinks it's some global function just sitting around doing whatever. So now it has access to product list. That's why it changed color and all the error went away. So that's good. See, live television, I'm leaving some of these errors in so that you can see the kind of process I would go through. Add item. We're going to add item, new item, get name. That's for just the list widget. So this is just for viewing. For viewing, we're going to just add the new item's name. Now, because we're doing these at the same time, they're going to be part of what we would call a parallel array or parallel vector, parallel list. That means as you add items or remove items, we're going to keep them parallel in the two different structures. There's the visual structure, the list products right here, and then there's the data model product list. That's the vector that we're actually putting the full item information in. So that's pretty cool. We've got that. Great, so let's test it out. So what we're going to do is I'm going to build it. So build all projects or build this project, doesn't really matter. Once that's done, we'll go to build run. All right. So let's make sure that the text appears in the product list widget in the main window once we create that new product. So file new product. It did launch the add item, which we wanted. That's good. So let's do, you know what? Let's do apple. I'm going to do 5 apples, and we'll say load image. And this is store inventory app. There's not anything in that directory, but I actually created an images folder, downloaded the images folder. So I'm going to double click Apple, and it will actually load that Apple image. And you'll actually notice that it is putting it in a local folder called images, and it moved the apple, or copied apple into here too, because we told it to. Pretty cool. Confirm add. Now apple's there. When I click on it, it doesn't really do anything, but it's in the list, and that's what we want. So that's awesome. Seems to be working great so far. We now need to add functionality for the button on the main window. So now we're in the main window. On the main window, we have this remove selected product button. So we need to add some functionality to that. So I have a challenge for you. This will require you likely to look up some reference material on your own and use your own knowledge of Qt and general C++ to solve the problem. You have many of the tools to solve this problem already at your disposal. You just have to really think about it and think it through before you implement it. I want you to implement the functionality for the remove button. Remember that you have to remove the item from both the product list, the Q vector, as well as the list widget that is visible in the main window. Just like we had to add to that, we have to remove it. Now, remove selected product does not have a separate window, right? You're just going to select an item in the list, hit remove selected product, and it will remove it. So some helpful hints that I have for you is, for the list widget, I encourage you to consider that the method current row can be called on the list, meaning the list widget, the visual list, to get the index of the element that is selected. It returns a -1 if nothing is selected. That's important too. You can also call delete directly on the element returned by the list widget's current item method to remove it from the list. For the items that are removed from vector, remember that you have to return the memory that the objects themselves are using. So as far as the vector is concerned, since the elements in the vector are raw pointers to item objects, you have to return that memory. But you also have to remove the element, the pointer itself, from the vector. Don't just do that, otherwise you'll have a memory leak. Okay? So don't forget to test it out too. So pause the video, take your time, and do your best. Come back when you're done, or if you need some help. How did that work out for you? That one was a little challenging, so don't be discouraged if you had difficulty with it. Even if you're an advanced developer and you had some challenges with it, it's not really a big deal. If you completed it, though, great job. So let's work on it together. So we'll go into the .h file for the main window here. And the thing we need to add in here first is remove selected product. There we go. And then we're going to update the .cpp file corresponding to the .h file for main window. We have to add the remove selected product here. No implementation yet. And we need to connect it. So for this one, we're going to actually connect the btn remove. And then that is a Q push button. Clicked. This. And then main window. Remove selected product. So far, so good. So now, inside of the remove selected product method skeleton that we've created here, I'm going to grab the index from the list products, current row, not current item, current row. And then if it's a valid index, that means the index is not equal to -1, but I would equally, you could just do this, right? Selected product, and if. Okay, so if it's valid, then we're going to remove from the vector, and then remove from list widget in the UI. Okay, let's start with the vector. So, item star, the item, equals product list at the index, and then you can just call delete the item. That removes the actual object occupied by memory or occupied in memory rather. So we delete that, we return the memory, but now we have an opposite problem of what we would have had we not done this. We now have a dangling pointer just sitting inside of the vector. So product list dot remove at index. So after we've obtained and deleted the actual object, we then remove that pointer from the vector. Good. So no more dangling pointer, none of that stuff. And we delete the corresponding element right here, current item. That's represented by the same item at current row. And remember, these are parallel lists here. So we're good. And of course, we need to run it. So let's run it with debugger this time to see what happens, to make sure that the product list vector is being updated properly as well as the list widget. So I'm going to build it. And we could put breakpoints to show that the product's being removed. So I could put a little bit of a little red symbol here. You just click in the margin, it toggles it. And we could just double check to make sure that it's working. I'll go to debug, start debugging, and start debugging startup project. Let's run this. Give it a few seconds to attach to the debugger. And now I have to add a product in order to remove it, right? So don't need an image necessarily, so I'm just going to confirm add. And let's add another product. We'll say apple. I won't use the image this time, but let's remove fudge. So I'm going to click remove selected product, and it pauses and goes into the debugger. And we're going to verify that it's removing it from our product list. What we can do is add a watch in order to look at what it's doing. So I can say product list. And there we go. That's product list. It added it to our little watch list here. And we can expand it. And currently we see that there is the none.png and then this not accessible quantity because we just deleted it, right? But it's still pointing to it. That's the whole problem. And we need to make sure that it gets removed. So let's make sure that when we step, if I go here and I go to step over, it's going to no longer be in the product list. Pretty cool. So now, if I just tell it to make sure it keeps working. Okay. Got this. Rerun. I'm going to add new product. We'll say apple and confirm the add. I'm actually going to put a breakpoint up here this time. And we're going to do fudge again. All right. And let's remove apple this time. So if I hit remove selected product, you notice both of the images in here actually exist. Everything's fine. They're valid references. But when I hit step over and do it again, once I call delete, it now removes it from memory, but that memory address is still stored in the vector. We want to fix that. So again, we have called remove at. So I'm going to hit step over again, and there we go. No longer in there. So I can tell it to stop the debugger or restart, whatever I want to do. There we go. We've verified that it works. Awesome work, everyone. That's fantastic. We're well on our way to making an awesome little application. In the next lecture, we will continue to add more functionality, including showing the currently selected product's information, as well as being able to edit and update the selected product. I'll see you in the next lecture.